Hi guys, welcome to the examples video for lesson 6.5 on limits. In this video we'll go through 5 more sequences and figure out if they have a limit or not. So, first sequence, this is a totally classic type of sequence to look at for a limit. So we're starting at 27, going down to 9, 3, 1, 1/3, 1/9, 1/27. So you might notice that what we're doing here is dividing by 3 each time. And we notice that as we divide by 3, we eventually get into fraction territory, and those fractions are getting smaller and smaller and smaller. So the fractions are getting smaller and smaller. Okay. The question is, are we approaching a single number? So to see that for this sequence, I'm going to use an analogy. Say you start off with 27 pieces of pizza, and then I say you can only keep 1/3 of that. So now you have 9, and you can only keep 1/3 of that, so now you're down to 3. You can only keep 1/3 of that, so now you're down to 1 piece of pizza. You can only keep 1/3 of that, so now you're at 1/3 of a slice, 1/9 of a slice, 1/27 of a slice. If I keep taking 2/3 of your pizza, so you're only left with 1/3 each time, eventually you're going to have how much pizza? Basically none, right? Like you're going to have a tiny little sliver of pizza, but that's basically no pizza. And as I keep taking your pizza and you only have 1/3 left, you're going to get closer and closer and closer to having no pizza. So ultimately, as our fractions get smaller and smaller, we're approaching the number 0. So this sequence approaches 0, which means that's our limit. We're approaching a single number. So we have a limit. Yay! Exciting. Okay, that's it for the first one. Next sequence, 8, 10, 8, 10, 8, 10. So question is, are we approaching a single number here? And we can see that we're bouncing between 2 numbers. So we're not approaching a single number. So that means this sequence does not have a limit, or we say the limit does not exist, DNE. The limit does not exist. Okay, that's it. That's all we have to do. And this is your explanation, so not approaching a single number, because we're bouncing between 2 values. Okay, next sequence, 14, 13, 12, 11, 11, 11, 11. So right here we see that the terms stop changing. And this is basically the easiest case for a limit. If the terms stop changing, your long-term value is really obvious, right? The long-term value of the sequence is just 11. It's going to be 11 forever. So our limit is 11. That just made me think of Stranger Things. Okay, next sequence, 0, -5, -10, -15, -20, -25. So pretty clear our sequence is an arithmetic, subtracting 5 each time. So we want to ask ourselves, are we approaching a single number as we go farther out in our sequence? And as we go farther out, this sequence is going to keep decreasing. It's going to keep getting more and more negative. So we're not going to approach a single number. So that means this sequence does not have a limit. The limit does not exist. So eventually, if you keep going, you're going to be at like -1,000,000, negative 2 million, negative 5 million. So you're not getting closer and closer to a particular thing. Okay, ooh, I'm gonna break out the purple pen. Exciting, I don't get to do that very often. 2, negative 2, 4, negative 4, 6, negative 6, 8, negative 8. What's going on with this? Are we getting closer and closer to a single number? Well, it seems like we've got two things going on. We've got bouncing. We're bouncing between positive and negative. And then we're also kind of like diverging from each other, right? So like every other term is getting bigger and bigger and bigger, and then every other term is getting more and more and more negative. So this sequence is bouncing around between positive and negative, and it's not approaching a single number. So again, we have a limit that does not exist. Okay, so I hope this helped you get a better understanding of how to find a limit or how to determine if it does not exist. Thanks for watching, and I hope you guys have a great day.